Before starting the PowerPoint, I'd like to thank you all for welcoming me in your group. I'm not a violin maker myself. I've been around for a couple of decades now, but I've met some of you. We exchange emails with some others of you, but I'm very happy to be here and to share. So thank you, Claudia, for the invitation, and you all for having me. It was very interesting to listen to George in particular. I think there will be, do you see the screen okay now? Is the file sharing?
Yes.
Okay, thank you. So while I have the PowerPoint, I cannot see any chat comments anymore. So Claudia, you're the host. Okay, you yes. Tell. Okay. So the idea, it's like a follow-up to George Stopani discussion. So I hope you are not fed up with molecules and schematics of molecules and cookings. We are going to discuss that a bit again. I apologize because some of my slides will have their text in French. So for those who get French, it will be easier. For the others, I will speak in English to go aloud on top of this slide. A few words of who I am, a short bio of mine, if you don't mind, just for those who don't know me. I have a strange curriculum or resume. I'm trained myself as a chemist. I have a diplôme d'ingénieur in French. It's a master's in chemistry equivalent in France. I graduated in '98. And very soon after that, after a few short term in a university and research centers, I entered the music museum, le Musée de la Musique in Paris, where I am still employed today. So it's been more than 20 years I've entered this institution, French institution. And I had a brief stop in my career. I left and I went on the West Coast of the USA to be a research fellow at the National Gallery of Art. And I learned a lot, for instance, about linseed oil chemistry because of easel paintings and historical paintings containing linseed oil. Then I came back to the Musée de la Musique, got back my position as a conservation scientist, where I had been before. And during this second half of my career in the lab at the Musée de la Musique, I prepared my PhD in chemistry again. And the topic was varnishing techniques of violin makers and instrument makers of the past, so 16th to 18th century. And the approach was, I will discuss this approach later in my talk. And after that, at some point in 2014, I had another position. I was offered another position in the museum. So I left the lab. I was not employed as a conservation scientist anymore. I became curator. So it's totally different job in the same institution and on the same instruments or museum instruments. So I'm in charge of all the stringed instruments of the collection now. I have been since 2014. I hope my English is correct enough. I have a beautiful French accent. I hope you don't mind. A few words on where I am, and I hope you can visit us very soon again, as soon as travels are easier and safe. So the Cité de la Musique, Philharmonie de Paris, is a very large music-related institution in Paris. It's probably the largest institution in France. And it has, it's in the northeast of Paris and very close to the Conservatoire. And it has three important venues, concert halls. This is the largest one and most recent one. This is 2,400 seats. We have also two other smaller venues like 900 seats and 240 seats. There is also a lot of education programs for kids to get a grasp on instruments, and of course, there is a musée inside this institution. So the Musée de la Musique, where I'm employed, is part of this institution. It is a department of this large institution related to music. So you have a small views here of the collection, of the galleries actually. We show in the galleries for the usual visitor are about 1,000 artifacts on view. It's not only instruments, but also paintings, sculptures, etc., related to the music, variety of music practices in times and places. And in total, we have about 7,000 items in collection. This is the French national collection. So it means it's not a privately held collection, it's owned by the French state. So the whole French people own the collection, if you want. Basically, it's a public collection, and it's make it very interesting to be accessible for access. So these are a few views of the museums for those who hadn't come. An interesting point, and it makes an interesting asset for the collection, is that it's one of the oldest music museums which is still open. And it means that many instruments entered the collection a long time ago, and they were then not used anymore or not too much maintained in playing condition or length, etc. This means in the past century, more than a century, they have been suffering different things, but actually less wear due to their playing and less modification, less modernization. I'm not saying they were known, I'm saying there were less modifications. The focus for you guys is mostly violins, I believe, I understood. And you may know these 5 guys, the usual suspects in the museum for you. They are the most demanding instrument when you want to come and study on appointment the instruments. We have these 5 violins, and you see, do you see my arrow when I move it on the screen? Yeah, maybe. Yes, okay. So they all were bequeathed to the museum long time ago. And they are considered to be for most of them, in very, very good state of preservation and very interesting, actually, historical artifacts to study. I show you one of them, which is named the Sarasate, on which I made a lot of research recently on his history and provenance, but it's not the topic of today, so I will move on. A few other ceremonies. We have about 1,200 bowed string instruments and bows in the collection. So 800 instruments of the quartet family, of the violin family, and approximately 400 bows for the same family. This is the most recent acquisition. It's like the first public announcement I'm making now. So there has not been the press release yet. We just purchased that instrument that most of you are familiar with. It's one of the 3 bass violin by Andrea Amati, decorated with the emblems of Charles IX, the King of France. There will be more to come on this object in the coming months, just showing we are very happy to have concluded the deal recently. One important thing with this collection, it's open to you, not only behind glass cases, but it's open to you for study on appointment. So usually it's not more than 2 instruments per day, because we want to have you sufficient time with each artifact. And also it's a big mess to move all these instruments out of the showcase for just a glimpse of 10 minutes. So you will be able to contact me. I will give you my contact information at the end, so that when times are safe and okay to travel, you can come and study these instruments in this type of environment. We conduct research in the Musée de la Musique, Also, we have équipe conservation research. So the curator and the colleagues of the lab, we are conducting research as well to the regular job. So we are conducting research based on the collection we are keeping. So the main focus, and I'm saying this introduction for the varnish thing after, is we are considering the starting point, if you want, is to consider the historical artifacts, the objects of the past we are keeping, as historical sources. Like most historians, they have texts, manuscripts, old books of the time, works of art, iconography. What we have is mainly instruments, and we want to look in the matter, in the composition, if you want to say, and the making of these objects, what we can learn from the past. So in a way, if you have a parchment, or I don't know, a manuscript from the 17th century, you just have to read it to know what it's giving it to you. But here, in order to read the matter of this object, we are reading the matter. It's not written with letters and words. It's written with molecules, layers, etc. So the job is to find methods to be able to decipher, to read in the matter of these objects of the past, things that we don't have in written text. We have no known manuscript handwritten by any of the Amati family. We don't have their varnish recipe. Andrea or Girolamo or Niccolo didn't write anything, and we don't have it. So we need to go in the matter to learn about that. And it's the same for Strad and the other guys. So this is how we are doing it. I'm skipping a bit that I said. This is the link, and I will forward it to you in the chat box. If you want to skim in the collection and to know, and look in this collection database, this is the link for that. Moving on. Now I'm starting really to talk on the varnish. I'm showing to you probably the oldest string instrument we have in the collection. It's not a violin. It's a lute by Laux Mahler, who was a very renowned lute maker in the first half of the 16th century. So this is very, very old, like for this wooden, thin, fragile, combustible instruments. So the varnish is very interesting. It appears very dark today, but it's a deep red varnish. It's very interesting varnish. And we have Laux Mahler in Bologna. He had a brother who was also in the lute making business. And we have this sentence that the Duke of Ferrara, you may know the story, the Duke of Ferrara sent a guy, Jacopo degli Tibaldi, to see Mr. Mahler to ask him about the varnish recipe. And it was way before Strad and the Cremonese. And so the guy writes a letter to the Duke who commissioned him, and he says, the famous lute maker, Sigismund Mahler, promised me to give me in written form next Monday the recipe of the varnish he is using, also the way he applies it onto the lutes. So it says the interest into, I mean, the same interest we have was already existing on January 20th of the year 1526. So it's a half a millenary ago. And the question was already pending. And the sad thing is we don't have the following letter. So we don't know if the recipe was ever given to him. And it was 500 years ago. Shortly closer to us, you have this beautiful engraving, you know, and the job of the Lautenmacher, of the lute maker, is described in like a little poetry. And this last, almost the last line, it says, I have varnished the enclasped, the body, and the, I don't know how to translate, but I have varnished parts of the of the lute, of the instrument. It means, to me, it's kind of a hint to answer the question about, was the instrument maker varnishing himself or not? Yes, he was, obviously. And we have also traces in the Logsmaler workshop that the whole upper floor of the building he was owning was dedicated to varnish and drying the lutes he was producing in Bologna in the first half of the 16th century. Why today should we study this historical varnish? I'm not answering instead of you. You know better than I, very much, very probably. But why would I dedicate some time, like 10 years, to study them? It's, to me, it's to read into the past and to read better about materials, like the recipe, but also application technique, but also aging and conservation of these objects. We need to analyze them, these old varnishes, also to better preserve them. This is for the museum part. But for the historian part, it is to know more. And also, we are here to give and to share, and we are here together to give and to share. It's also to maybe put some technological means that are more in the hands, in France at least, of public research labs, heavy equipment, etc., to conduct projects and analysis, to disseminate in the end the results of what we found. We'll never be violin makers, we'll never be good varnishers. You are the good varnishers. As curator or researchers in labs, we don't know how to make a violin. We don't even know what is a beautiful varnish. You know how to look at them. But we may be able to share and to discuss, to join our efforts. The varnish, to me, can be taken in various ways. When you start with the word varnish, you could want to study it as a multi-layer system, as a recipe, a formulation. You may want to study the effect of time. Just some of you just care about how it looks, or is it resistant or not, chemical properties, mechanical properties, which may be linked to, of course, abrasion, etc., but also to sound, acoustics, vibrations. And this is just a schematic to say how it is complex to go into the varnish topic. The varnish topic can be approached in many, many ways. And it's like a fractal thing you could develop all the time. If you go in the formulation, you may want to go in the process or in the ingredients. For the ingredients, you may do chemical analysis, but you may want to look at old recipes, but also be interested in the trade and the suppliers of each of the ingredients. If you want to go on effect of time, you need to say, okay, is the material aging itself, or is the man modifying it? Has there been conservation treatments? Is it evolving with time, etc.? And in fact, my point is with this, I hope, funny slide, is to say that many, many fields of knowledge can be used fruitfully to learn something about varnishes. It could go from mechanics and acoustics to history of trade, to history of conservation practice, to cognitive processes of like the history of taste, the history of vision, how people see things and perceive things, and what is important to some culture and what is not important to some of them. So it can be approached in many ways, and the few links, the few lines I've designed in blue and orange, the color are meaningless here, is to show that everything is interwoven. Everything is linked and interwoven. So this is very much a complex field. And there will, to my mind, never be a definitive answer about the varnish of violins. There is not one varnish, there are plenty of varnishes, and depending of every individual, you may want to focus more energy, more time, more interest into this or that of all these aspects. So myself, I've approached it in various ways, but the start was this PhD it was quite a while ago already. And the idea was to find a balance between the history of texts and what can be found in written texts about varnishes, not only of violins, but varnishes. How would one varnish something in this time period, 16th to 18th century? And also the other side of the project was to observe and analyze old varnishes, and especially from the Paris collection. We have this painting, this portrait by Nicolas Lupeault in the museum, and it's a very inspiring painting. And I relate it to what he expressed about the varnish. So Lupeault was one of the first, let's say, 1806, these are the beginning of the chemistry, and George told us about what was chemistry and atoms and molecules, etc. And Sibir and Lupeault, it's just after Lavoisier discussed, and his colleagues discussed this early aspect of the matter and knowing the matter, and this is the birth of modern chemistry. And at the same time, it's the birth of writing treatises on how to make violin. There is Marchi in Italy, and then there is Sibir and Lupeault. And what they write is, okay, spirit varnishes are no good. This is really crap. And it challenges the most skilled chemist who would be able to decompose the varnish Lupeault recreated to find his elements. These are the same that those who are in the beautiful varnish by Stradivar. So Lupeault claims to have found the elements of the Stradivari varnish. And it's very interesting that already in these very early writings about old violins, about Cremonese violins, classic varnishes, there is already the notion of decomposition. Decomposition, it's analytical chemistry in modern words, and to find the elements, which are the molecules. And we are in the same mood. At the same time, there is obviously the myth, and you all know this painting, and you know that the varnish flask is in the very center of the composition of the paint. Here I cropped a bit the thing. And we may question this vision nowadays, and I'm sure you're questioning this vision all the time at your workshops. 1880 in the New York Times, so a very general audience reading, there is the story of the famous old violins, and especially the notion of that it is a lost varnish. Lost varnish. I don't know if you think it's lost still, but I don't know. Another link between chemistry and violin is this guy. You may be more familiar with the violin itself on the right than the guy on the left, but the guy on the left was a very important chemist of the 18th century. He was rich, he made his wealth with creating Movein and molecules derived from tar, pitch, tar, something like you find in the earth, in the mines in UK. And from the tar industry, he developed artificial dyes, including the Movein. And he made his wealth. He was very healthy and he retired at 36, lucky guy. And well, he created a quartet with his family members and he purchased Guarneries and Strads, including this Strad, which is now named the Perkin, following his name. And there is this story by Reverend Hawais, who gave lecture on the varnishes in the late 19th century, that Perkin scraped a huge part of the back of the varnish, like almost half of the back of the varnish of his granary to analyze the varnish. We don't have the report of the analysis. It's not been published, though. Half the back of the violin is gone. So I'll skip that, old books. Yeah. You know that very easily, but when you need to talk the problem, tell the problem, transfer the problem to chemists of nowadays, you need to simplify the thing. I'll come back to simplification later, but there are various types of varnish, and it's a question, even if, let's say we don't know nothing about varnishes. We just read the books that have been published and every analysis that has been published. So we could say there are three main issues. Is the varnish spirit-based, oil-based, or oil-based, drying oil-based, or like turpentine oil or spirit of turpentine based? Like, is there a solvent or not? Is it polymerizing or not? The second question is about the ingredients. What is in there? The ingredients, if you look at the literature on that, you'll see that everyone has found his own secret ingredient. It could be puzzolana, propolis, I have plenty of them, saffron, dragon's blood, whatever, potassium silicate. Everybody has claimed to have found the secret ingredient in the literature, I mean. So we could bring something with analytical chemistry to at least reduce the field of possibilities. And finally, what is the origin of the color? Is the origin of the color wood staining? Is it in the ground layer in the upper layers? Is it vegetal dyes? Is it colored gums or resins? Is it metallic salts? Is it lake pigments? Or is it only the effect of time and aging? So these were the three main questions. We looked at recipes. We looked at almost 400 recipes. We created an online database you can search into. And we tried to find what were the trends among this general question. We couldn't find many things. But it appears, you may see on this histogram here, that the more you progress in time, the more you have spirit varnishes popping up. And the relative proportion of drying oil varnishes, in relative proportion, it's diminishing. It can be, it's too long here to discuss this specific point, but I would like just to point out that spirits, like the distillate of wine, for instance, ethanol or alcohol, was in the Middle Ages only dedicated to pharmaceutical and medicinal uses. As a distillate, obviously, as like the alcohol you would use as a solvent now. It was reserved, and there were like trade regulations and who was authorized to make it. It would be reserved for this kind of purposes, medicinal, pharmaceutical. And it's only in the 17th century that progressively there was negotiation between pharmacists or apothecaries and like the Vinegar Makers Guild. They would negotiate and finally obtain the right to produce spirits from alcohol. And this is where progressively spirit was used as a vehicle for resins to solubilize temporarily resins to make spirit varnishes. And I think this is illustrating in back and forth how the violin, like research in violin history, can learn from more general history of how the trades and regulations work at a specific time in a specific region or city. I'm skipping that. And I'm going to this very, I don't know, do you know this cartoon? I'm not sure you know it, but I hope you like it. It's a big shortcut to me. It's a terrific shortcut, but horrible shortcut as well. And I'm trying to, in the rest of my lecture, to show that, well, it's not the thing, probably. It's not the way to go. So varnishes are on a variety of instruments. My point was in the PhD to not only look at violins and not only look at cremona, but to look at variety of region of making centers in Europe and to look at a variety of type of instruments that have been varnished. Because basically, if you want to find when sampling objects or studying the varnishes and their composition, if you want to find a specificity for Strad varnishes or Cremonese varnishes, you need together and with the same method, you need to compare with other production center, other traditions. So it was the main drawback of my literature review of people who have studied that in the past. I mean, Perkin, Fry, Michelman, Condax, they did a huge and great job, and Claire Barlow and Jim Woodhouse, etc. But Claire started that. Roger White also started that in London in the 80s. But there was very little instruments that were studied which were not violins. And the same statistic applies for non-Cremonese instruments. Non-Cremonese instruments were rarely, very rarely analyzed. So we need to I did so that we study many more instruments than just Cremonese instruments. I decided to simplify again, it was in 2006, to simplify the topic by describing simply a varnish like a multi-layer structure, and the number of layers is not known, and saying that each layer has a specific chemical composition. And as George pointed out earlier this afternoon, there are organic matter, there is organic matter, mineral matter or inorganic matter, and these matters can be mixed. So you can have a mixture of organic and mineral, and all that is arranged in what I call a structure. So it's like a layer system with thicknesses, interfaces, number of layers. And all this has to, in my view, the ideal was to try to describe each layer in its physical properties, so like thickness, etc., its position in the stratigraphy, as well as its individual composition. It was a huge challenge. So I applied a series of observation techniques, first without any sample. So this is an X-ray technique to analyze the composition. And so various in-situ techniques. And then once we have done that, we were able to determine if there was a place on the instrument where there was a chance that a tiny area would still be representing what the composition or the ingredients of the original varnish. And it's really tricky, you know. So we took a lot of efforts to determine the best location, if there was one, on the instrument to sample a piece of varnish down to the wood. So we would sample including wood to have the layer structure and to have a relevant thing. It was no use to sample a retouch. So it took us a lot of time. Basically, we were the two of us with a microscope, and we spent almost 3 to 4 days on one instrument, each instrument, to choose the best area to make the sample. So I insist on that. Many good researches have been performed on samples that were not enough historically informed, historically relevant. And analysis have been performed with great techniques and by great researchers, but on samples that were not sufficiently expertised, authenticated, if you want, if I may draw the parallel. And then we've performed again a series of imaging techniques, chemical techniques, and chemical imaging techniques to have the localization of the ingredients in the sample. And in the end, this is the red technique, we sampled in the sample to sample just one layer or that other layer, and we burnt it into a machine to analyze the molecules. So this is totally destructive, but we are destructing a micro part of the sample that was taken and which we had already observed by a variety of techniques. So the idea was to, with a minimal invasiveness, to get as many information as we could in terms of layer structure, mineral composition, organic composition. This is a view of in-situ observation. So we purchased a microscope. So it's a very high magnification light microscope, but under which you are able to fit a huge instrument. I mean, an instrument, not only a sample. And you see on the right a typical view. So it's difficult to see, but the red particles, they show different sizes. And also this, the refractive index of these particles is very close to the binding medium. So it tells you a bit about the chemical property. I'll come back to their analysis after that. Also, we observed on we observed other particles, red particles. Some of them were more opaque. So you see on the bottom left here of the slide, more opaque red particles. This is in the Sarasate strand of the collection. And using X-ray fluorescence spectrometry without samples, we detected mercury. And mercury associated with these red opaque particles, you could determine this was vermilion or cinnabar, which is a very well-known artist red pigment. It was, to my knowledge, I believe the first discovery of red vermilion particle in strad varnishes. We studied the layer structure by careful sample preparation, studying the layers. You might have seen this photograph already, but not with the add-on of the PowerPoint. We developed a very special technique to be able to analyze the layer structure with a variety of spectrometries and microscopical techniques. And it involved a very thin slicing of the sample. And it's coming from, you know, it's called transmission microscopy techniques when people are studying, I don't know, there are ultra slicing brain cells of mice in labs, etc. So we went to this kind of lab to ultra slice, it's called ultra microtomy, ultra slice samples. So this way, in the thickness perpendicular to the image you see, it's I believe 3 micrometer thick, the sample. So it's very brittle. So you see in some areas it has cracked here, the upper layer, because the layer is very thin. It's like when you're cutting, I don't know, Italian ham, you know, but very, very thin. At some point, the layer breaks. This is what happens. But still, you have a very good ability to distinguish layers with no contamination of outer components. And we went to a synchrotron to make chemical maps. And the idea was to use a very powerful light source. So it's a synchrotron, it's a particle ring accelerator. And this way you can have chemical analysis with pixels which are smaller than the layer thickness. So you see each pixel represents a spectrum on the map, and we were able to localize and make the chemical composition of each layer individually. So I'll sum up here. So this is on a Strad, on the Provini of the collection. And this is on the bouquet cello, a French Parisian contemporary cello. And you see here, the layer was very brittle, and most of it, of the upper layer, has gone when preparing the sample. Anyway, we mapped it. And in green, we mapped signals relevant for cellulose, in blue for proteins, and in red for oil and resins. And you see here that on top of the cellulose, on top of wood, the first layer you see in electron microscopy appearing this way, the first layer is rich in blue pixels. Blue pixels is proteins. And red pixel is oil resin. And this allows to tell us that the bouquet was varnishing with first by sealing the wood with a sizing, a glue sizing, something like that. And on top, you would apply oil and a mixture of oil and resin. If you go back to the Strad, you see very rare blue points, that are, when we studied specifically these pixels on the spectra, it's artifacts. It's not a real blue signal of protein. And it's mainly red, the lower layer, the first layer. So the difference is in the first layer, the first stratum. You may call it ground, but some people don't call it ground. So I say first stratum, the first thing applied onto the wood. And then we can compare the two. And the difference is really visible. And the difference is in the first stratum onto the wood, not the second stratum, very much at this stage. It's very difficult with this technique, though, how it's very powerful, but it's not a molecular analysis. As George showed, a lot of chemical functions are similar in oils, in drying oils, and in terpenic resins. So this method, infrared spectroscopy, is not very well designed to distinguish between oil alone, resin alone, or a mixture of the two. For that, you would need to study another molecular technique with samples, and it's called gas chromatography and mass spectrometry technique. You don't need to remember that, but basically, each little mark, yellow or green, each peak corresponds to a specific molecule. So here we are decomposing the matter into the diversity of molecules. And each peak corresponds to an individualized molecule, and the technique is allowing that. And after that, I was able, the machine, the computer, and I, it's a big trio, we were able to recognize molecules. With molecules, you can go and say if it's only resin, if it's only oil, or if it's a mixture of the two, and which kind of resin is it? Because the molecules, like all the green molecules marked here, are like fingerprint for a type of resin. This spectrum, for instance, is showing the analysis of the upper stratum of the Davidoff violin we have in the collection, a 1708 violin. The upper layer was specifically sampled here and was analyzed. And we see very clear fingerprints for a drying oil. So it could be linseed or walnut. We don't know very well, but it's either linseed oil or walnut oil for the yellow marks, and the green marks all point to a conifer resin of this Pinaceae family, so the family of pines. It could be large, it could be spruce, it could be pine and fir. It's not more precise than that because the resins have aged and they all oxidize towards the same fingerprint. But at least it's what we have detected so far is drying oil and one pine resin. We don't know if it's rosin or turpentine of these trees, which is common. We don't know the level of transformation by the man before being incorporated into the varnish, but we identify these two ingredients. Now, if we leave a little bit the spectrometers and the chromatographs, and we make a summary of what we found for some question. One question is the nature of the underlying stratum. Sorry for the typo in the title. And we found that the first stratum, the first stratum applied onto the wood was very rich in protein materials, like this sizing I have showed you with the blue pixels before. And for instruments on which we have been able to analyze this first layer in Italy, you see Lochsmaler and Strad, it's oil rich, drying oil rich, without any resin. For the upper stratum, for the second layer or upper layer, we see that it's way more even, or basically everyone is varnishing with a drying oil mixed to pine resin. The results are amazingly similar on all these instruments. A few of them, there is a rare Colichon bass viol 1683, which is only shellac. So a very early use, according to my analysis, very early use of a spirit varnish, shellac in alcohol. And another shellac later in the 18th century in Barcelona. Otherwise, it's mostly pine resin plus drying oil. You would say, what about the minerals? You didn't talk about minerals, JP. Well, when I started, it was in 2005, my first analysis were to look for minerals because I had been very much inspired by the works of Alex van Bollen in Germany, but mainly from Claire Barlow and Jim Woodhouse, what they had done. And I designed my first experiment to reproduce what they had done. And sadly, it was a huge failure on the instruments I would samples on. And here you see, so using a similar technique to Claire Barlow and Jim Woodhouse, I use SEM, just maybe slightly more modern instrument because I was way after them, but, and there was no mineral. So I just show you one picture of the Provigny here. In the one, these are the cellulose walls here of the wood cells of the spruce here. And in second here, it's the first pores of the wood. You still distinguish a bit the cell walls of cellulose, but it's filled with matter, and EDAX analysis, like the technique mentioned George earlier, EDAX showed that there was nothing but carbon, hydrogen, carbon and oxygen. We couldn't detect hydrogen with this technique. So it was purely organic. And I'm just showing one view here, but there was no particles there to be found in the underlying stratum, not in the wood either. And in the upper layer, it was mainly organic with rare traces of aluminum, and I'll come back to that later. Aluminum was related to dye stuff, to pigments. We observed red particles in some varnishes, and I've shown that to you earlier. We applied a very specific technique to detect the molecules for these dyes when there was only very organic rich dyes. And we found, this is a grain, again coming from the Provigny 1716 Strad. we distinguished, and this is the Provini analysis, a Raman spectrum. Raman is a very specific kind of laser excitation spectrometry, laser excited spectrometry. And it was clearly an organic molecule from the anthracinoid family of molecules, and it's a family of dye stuff. Oh, is it correct in English? Molecules that have a color, organic molecules which have colors. And it's a family of molecules that can be produced either by vegetals in the root of madder. So madder contain alizarin, this molecule, and purpurine, this molecule as well. And cochineal, like the Mexican cochineal, is producing mainly acid carminic, which is the dye stuff from the cochineal of Mexico. And the Provini and the other strads of the golden period were containing red particles showing this kind of spectra. So we concluded that it was first an organic dye, which was coloring in red these red semi-transparent particles in the golden period upper layers, but also that it was certainly cochineal, the one from Mexico. And we decided, I mean, the experimental data were kind of not pointing, they were more pointing to carminic acid than to alizarin. But you always need to take into account the fact that these molecules may have aged and degraded, being mixed to the oil resin mixture. So this experimental data, it's showing that it's a red dye stuff from the anthracinoid. And the decision to conclude with my colleagues that it was Mexican cochineal, it was using the history of trade. So we looked in a publication and papers of the trade of cochineal in Europe between the 16th and the 18th century. And in 1716, the Spanish had already a monopoly of the red dye stuff, and like 98% of the red anthracinoid dye stuff traded in the whole Europe was Mexican cochineal imported by the Spanish. So this is why to us, it's very probable that it was the red Mexican cochineal, which was in the strad varnishes of the golden period. In addition to that, and you may know that there is a problem of light fastness of this kind of dyes. The color disappears when being exposed too long to light. But in fact, there is chemistry to stabilize that, and typically to precipitate it onto aluminum. And using, how do you call, alume di rocca in Italian, potash alum, maybe in English, alum. You can co-precipitate the cochineal molecule onto aluminum. So you create what is called a lake pigment laqué on my slide. And we have proven it was there in the strad varnishes. So we detected with SEM, with the scanning electron microscope, we detected aluminum in the same place you would see red semi-transparent particles and where you would detect the carminic acid spectrum. So it's like a crossing of several techniques to study both the position in the layer structure, the organic composition, and the mineral composition. This was the challenge of the PhD. And we saw that the origin of color, we studied a few instruments here, all were Italian, unfortunately, because we couldn't see on any of the Northern Europe instruments we had in the collection and I studied, we couldn't find any instrument that was exhibiting any visible particle under the microscope. So we didn't go into the pigment analysis for varnishes where no particles were visible. We just went onto the Italian ones where the particles were visible. Interestingly, the oldest dated instrument which was having red particles was a strad instrument dated 1708 for the one we studied. To sum up, I don't know how am I with time, and you interrupt me, Claudia, if I'm too long. Please. So it's a sum up.
Okay.
It's okay? Okay. Thank you. The results we had on the strad. So for some of them, we are able to have the first layer. So this is the underlying stratum, the first stratum onto the wood. And we never see any mineral there. We saw only oil. So to me, to my understanding, the main ingredient of this underlying stratum in these strads is just oil, just drying oil. Then for the second stratum, like what I call the upper stratum or the surface stratum, the organic composition was a mixture of oil and a pine resin. And in some instruments, we observed pigments, red pigments, admixed to this upper stratum. After my PhD, so I defended it 10 years ago. So I'm getting old now, and some things have went on with me in the museum and with colleagues of the CNRS, and we've developed more things. There was more research for new equipment to make less sample on the instruments and get better information. And it got various kind of developments to study various spectrometries. This was a very experimental stuff, but I really like the 3D animation here. It was on a model, on a mock-up varnish sample. We did the varnish sample on wood, but we investigated the first 3D chemical imaging of a varnish. We have not been able to apply it to get good results yet on a historical violin yet, but it's telling you the potential of chemical analysis. Here, each color, the green and the red color, are corresponding to specific chemical signals. So it's a very promising view. Right after my talk, I'm not interrupting here the screen sharing, but I will share with you a file sharing place, and I put all my publication and papers. Usually they are available behind paywalls. You need to pay to access these PDFs, but I will give them for you. I mean, don't put it online, but it will be available for a couple of days if you want to go into the very detail of everything I'm showing here. We mentioned, I believe, George, you mentioned that earlier, UV fluorescence, like the color of all these resins and materials under the UV light. And in fact, it's also chemical signatures, these colors. And you have these descriptions in the Sacconi book, for instance, of the colors of this, of that film of varnish. But in fact, you could color, the naming of color is very depending on the words you're using and the eye of everyone, etc. So it's very variable. And we have developed techniques to better read the signature and the color of these various varnishes. Are you dead or not? Someone say hello to say, I'm not dead. Are you okay?
Yeah, we're fine.
Okay, thank you.
Yes, we're all here.
Okay, good. It's very strange to have the screen sharing, etc. So I hope you don't mind. I hope it's not too weird the way I do. Now I switch on to another part, which is not my chemical analysis of old instruments. I'm switching to a part that is maybe closer to what you're doing, which is trying to recreate and understand what is happening in the kitchen, in the varnish making place. So from my results on the historical instruments, we saw that a very common mixture was oil plus resin, pine resin. So we decided to look at the ancient recipes that were describing how to make varnishes using only a drying oil and a pine resin. So sorry, these recipes are in French. I hope you don't mind. but I highlighted in red here. These are a few of the recipes, but they are actually, these are the most numerous recipes we find among the 400 ones. These are just, you mix very simply a pine resin plus drying oil. And in fact, you could, you see it's evolving now, okay? In red, you have the proportion of the two. So how much fraction of oil compared to the varnish, to the pine resin. So for the first one, it was 1 share of oil and 3 share of Greek peach, so colophony. And this one is 1 and 3 again, 1 and 3. But not always. Oh, sorry, I switch. I cannot, it's getting weird. Well, you have variation of proportion, okay? And you have things about the way you cook it, and you have information about the time of cooking, and also how you add them to another. So we transferred these variations to studying specific parameters. So we prepared varnishes and we analyzed them. So you will say these are ugly varnishes. Okay, I agree. We are basic chemists. We are not varnish makers. But we prepared mixture in various ways. So we changed the proportions, we changed the cooking time, and we changed the cooking temperature. These were the 3 parameters we used. And so cooking time, cooking temperature, and proportion in colophony. And we went from 0% of colophony to 100% colophony. And I believe, every 20%, something like that. And we did some chemistry on that to understand what was going on in the mixtures. Because so far, all the chemistry that had been done was considering the molecules of the oil on one side, the molecules of the pine resin on the other side, and not looking in the middle, what's happening for the intermediate proportion, when you have 20% of colophony, or 50% of colophony, or 70% of colophony. And in fact, it appears, and these are the area in yellow, that some molecules appear, they are very small molecules, but they appear very specifically in the mixtures when you mix the two. And this means that novel compounds appear in the mixture. So some molecules of the pine, I'm going slightly faster here, don't mind all the chemistry, but please, that there are specific compounds that are formed in the mixtures. It means that there are molecules which are mixed, and George, you showed that earlier. These are a bit of molecules of the oil, and they link to molecule of the resin. And these hybrid compounds were never described before. So it was a PhD student I had later. After my own PhD, I had another chemistry PhD student, and we discovered these new molecules. And they form in the mixture, and solely in the mixture, because you take a molecule A from the oil and a molecule B from the resin, and they attach to make a new hybrid component. We also studied how the distribution of the main molecules were to be found depending on the oil proportion. And you see that the polymerization that George was mentioning earlier doesn't happen the same way in the mixture. You would know that with your bench work, you know that, but we were able to describe it. And especially this hybrid component, this new component, they form at specific composition. So when you have 40%, 50% oil, this hybrid component forms it's major, it's a maximum. And basically the chemistry change of when you mixed the two of them. Molecules are not everything. is we did what is called rheology, and if you transfer it, it's how it applies. How does the layer behave when you apply your liquid on the surface? How does it dry? How does it level? How does it auto level? And this is related to the viscosity, rheology of the system. We had Tony Echavidre, a violin maker in Bordeaux. He made us, we give him the oil and the pine resin we were using for our experiments, and he made what he was calling a good varnish. And we studied how it behaved. It was very interesting, but it appeared that our varnishes that we are prepared in the chemistry lab were behaving the same. And you see the various colors depending on the resin proportion. It's written here. Here, it's a very rich in colophony, and here it's very rich in oil. And they behave differently, and they so you coat them more or less easily. So we studied various parameters, and we found that obviously, and you would know that, just like 20% of colophony cooked at a high temperature for a long time, it behaves very well. But what we found also is other mixtures were behaving very well also, that you could produce a well-behaving, a good coatable, do you say coatable? That you are able to coat well on a surface. It could behave well with a very rich colophony content, like 2/3 of colophony, 1/3 of oil. You cook it at a lower temperature and it behaves well as well. Just speaking about coating properties here. So you could play with at least these three parameters, proportion, cooking time, and cooking temperature in various ways and still obtain a varnish that has good coating and leveling properties. I'm not saying this is the full answer. I'm just like giving you bits of the little things we found. But there is what we learned from that. It's not only the numbers and the temperature, almost, they are just indications. What we learn is that there are varieties of ways to reach the same objective, the same behavior. If your idea is to have a varnish which is coating good, self-leveling while drying, there are various ways, various recipes with the same ingredients. And I find it very stimulating and very interesting. So I showed you that picture and I told you about simplification. I'm naming another guy of the past with a nice white bird who was saying that what is simple is always simplified. And when you simplified, when I talk to you, I simplify. I'm sacrificing other information. I'm mutilating the whole knowledge. We are just saying simple stuff, but everything should be more complex. Here I have, oh, what's happening? Oh, I don't know what's happening. And what we showed here, it's like complexity of the topic. And sorry, I'm going back to that again. And what I try to do, and what we try to do in the research, we almost went onto these topics in yellow. All the other ones we had not the time to study, and they all are important in some ways. And of course, we didn't went in depth with even the yellow part, even the chemical analysis. We used new and advanced techniques, but we were not able to do it on every instrument we wanted to have. So there is always a compromise, a bargain, and it depends on the money you put in, on the time you put in. So all this is very complex. All this is related. And by no means I mean to say that we have found an answer. We just hope that we have brought a few bricks of little knowledge, and I hope can make a use of it, even to criticize it. And obviously I gave the talk, but you cannot do that alone. I mean, I had almost, I don't know, 25, 30 people working with me, together with me in the past 15 years. So I'm grateful to them. And voila. So I'm just open for questions. I'm just telling you a few books that are, one is out, one is soon to be out, just if you want to know more about the museum and the collection. And you can reach me here. And I want to finish by reading a phrase, a sentence. And Claudia, you work in the lab of, that was maybe, can we say created by Émile Leip? Yeah?
Yeah.
Okay, so Émile Leip was a very important French acoustician for musical instruments, right? And in 1946, he self-published a book named Essai sur la lutherie, le vernis de Crémone. So I'm reading 5 lines to finish the talk, and he says, "It is perfectly possible to varnish in the Italian manner. The preparation of the varnish and the coating application of the varnish have an equal importance for the result. It is not enough to know a recipe to varnish perfectly. Those who have made the researches will understand that easily." So this was my concluding words. Thank you.
Thank you, Jean-Philippe. We can start. So Jacob has accepted to start his talk late, so we can have some time for questions.
May I begin?
Jessica.
First thing, very simple thing, the link you mentioned for the Vernix project of La Cité de la Musique,
yeah.
Was not functioning. So is it correct, or is has it changed?
It's okay. I should update it probably. Yeah, you're right.
Okay.
I'll try to do that right after. It's true that in the meantime, the institution name changed, and probably the stable URL was not in the.
And I was looking with the search, but I didn't find it. But I think it's very interesting to have access to these informations.
Yeah, I apologize for not updating.
No, but if you are open to share, it's
sure.
very interesting. You mentioned that the pine molecule, you cannot make difference between large or pine, etc. And is it the same with amber, fossilized resin? Yeah. Okay.
Okay, I see the question. I believe I understand. Amber is created by pines, but a very long time ago. But basically, the trees where amber was from are the ancestors of the trees that are today producing this kind of resins. It's not that simple. I'm simplifying again, but so the chemical composition is not very, I mean, the original chemical composition when all these things were fresh are not that different.
Okay.
There is a molecule which is called succinic acid. It's the name of the molecule, which is specific to amber that you find in fossil amber. I'm talking about the fossil amber, not amber varnish or this kind of thing. I'm just talking about the fossil amber. Succinic acid is a specific molecule. The issue is it is a very light molecule, a small molecule with not many atoms. And it's difficult to detect. So I may have missed it. I mean, not myself, not that I was not searching for amber as well. I was very open to detect a lot of ingredients, but this tiny molecule, this tiny peak, can be lost in the early eluting peak of the fatty acids. Okay. So it's always kind of lost in the noise, you would say, of the signals. So
no, my question was, okay, is it amber included in the different tiny?
It could be. Resins. It could be.
Okay.
The thing is, we have an issue of time and knowledge. When you go back in the history of knowledge of like 16th and 17th and 18th century, and you think also about what was available as materials, there was, of course, we have the molecular analysis tool today, but in the time, you can find recipes saying, and there is use fossil amber. There are synonyms for fossil ambers in old recipes. You could find it. But
is it Carabe?
Like Carabe, for instance, yeah. But also, it's well known that in the Vendecolori in Venezia, or Merchant of Colors, or Merchant of Apothecaries, in fact, there are no quality control in the way we think of it. And there were a lot of quid pro quo or adulteration of products, or, I mean, it was not, I mean.
It was not controlled as it is now.
Yeah, and it would be interesting to have a deep look into the trade of all these matters. And like, if we know there were like amber pickers on the beaches in the Baltic Sea, and they were trading a lot of amber throughout Europe in large quantities, etc., this would be the way to go to me. It's not only with the molecule.
Okay.
If I may answer this way, I'm not skipping it. I mean, I'm not.
The other question linked to that is what you mentioned, the Mayerne, and there is the recipe of the Mayerne about Carabe specifically mentioned for luthier, and so I didn't have the original source. I don't know if he is speaking about something else, saying something. So I am curious.
What says, I mean, it's really in the Mayerne manuscript. And the thing is, we don't know if the Mayerne was really linked with instrument makers. And we lack this kind of documentation. We lack to know, because there was a lot of recipes that were just copied and copied and copied. And they were not, the problem is we have no proof that they were really used in the workshops. This is the, yeah, I'm not forbidding, if I may say that way. I'm not excluding that amber was used this way.
Hi, Jean-Philippe. I have a question for you. Yeah. First, I want to thank you very much for the very nice lecture. And I have a first question. It's about how do you feel the pores when if you put the linseed oil on the raw wood like that? We all did the experience that the linseed oil will spread in the wood and soak the wood very much. So I don't understand. I think that we have to find something to protect the linseed oil to go deeply in the wood. So how do you feel the pores? That was my first question. And I have a second question about the temperature. I made a lot of varnish in my life. You only with colophany and linseed oil, and I noticed that the temperature is a crucial criteria in the result you can get. And I noticed also that higher I cook and the temperature, better is the result. Mm-hmm. So I finished now that I go up to 300 degrees, 320 degrees. And I get the best result with this kind of temperature. And when I ask to a chemist what's going on at this temperature, he tells me how it's almost impossible to say what's going on at this temperature. So it appears to me that the process of making and the temperature is also a crucial issue there. Yes. So how do you feel the pour? What about the temperature?
Yeah. These are important questions. I'll answer the first one only, and I'll tell you why I don't answer the second. No offense, François. The first one, the less oil you put, the less matter, the less it soaks. I've seen, and maybe Mr. Popiela might, is it?
Oh, excuse me.
Maybe can you mute your mic, please?
Oh, did you hear me?
Yeah.
Oh, excuse me.
That's okay. The less oil you put, thank you. The less oil you put, the less it will soak. And also it depends on the orientation of the vessels of the wood compared to the surface, the outer surface. Especially, for instance, on the head of the Viola d'Amore by Strad, we have this head coming from Vuillaume workshop. It's in our collection. It's a very thick varnish, beautiful red varnish, really mint example. And depending on where you look, the maple vessels are oriented in different ways, whether you are looking on the cheek or on the back. The orientation, relative orientation of the maple are different. And for some vessels, when they are way like very much open at where it's cut, the surface. I'm sorry, I'm not a woodworker in English, so I don't know how to say that. But it penetrates very deep the first oil layer. It penetrates almost 1 millimeter in the vessels that are perpendicular to the surface, or almost perpendicular. But on the spruce of the soundboard, given how it is carved, there is very few openings perpendicular to the surface. There are the openings of the vessels. I'm talking about the openings which are bigger than 1 micrometer. I'm talking about openings which are 5 to 10 micrometers. They are mostly in the bottom part. Yeah. And this could soak here, but depending on where the sample is and where you measure, it would soak. But since the vessels are almost parallel to the main axis of the table, you would have 1-2 vessels soaked, and that's it. It will not soak perpendicular to the surface. It would soak that way. I would need to make a drawing, but I can't here. And so this is my first answer. I think don't put a lot of oil. And maybe there is something linked to how you cook the oil, how you prepare the oil, how you thicken the oil before applying it. My results are not able to say. I'm just saying there are molecules of a drying oil, but I'm not able to say if it's pre-polymerized or not, if it's raw or not, etc. This is an open field of experimentation for you guys. This is, I'm serious. I mean, you are researchers as well as chemists, you know, as the chemists are. The second, can you remind me your second question, Denis? François, pardon.
For the temperature.
Temperature. as I said, there are many ways to achieve one objective. And my approach is not to tell you how you should do the thing. Don't have the answer. My approach was to study what was corresponding to the historical evidence I was finding in the historical sources, which are the violins of the collection. I'm just putting it here, but it's very limited, I know. I'm not saying which temperature it should be. The experiments we have tried to do is showing that many temperatures are possible, and you went to way higher temperature. My comment would be more historical. Who would they spend? What was it necessary to spend a lot of combustible to create a huge fire at this elevated temperature, to control it with the fire hazards, etc., in an environment? I mean, was it necessary or for them? I'm talking, if we want to speak about how the guys in the past would do, would they spend a lot of energy? I mean, you know, the cost in energy, it's not carbon cost, it's cost of, I don't know, burning wood. Would they do it? Was it necessary? I would more think that way, but my goal is not to tell you how to make a varnish now. My research is more trying to decipher how they were making varnish in the past.
Thank you.
Okay, thanks. There is a question from Christian.
Christian. Bonjour.
Yeah. Congratulations, Jean-Philippe. Nice to see you. I have a specific question, a practical question about the Provigny Valley, the beautiful varnish. And do you know some many varnish makers have a different treatment for the top of the maple? So where did you put your sample on?
The sample of the Provigny was performed on the top, in the area which is protected by the tailpiece. And it was on the treble side, about 5 millimeters away from the joint.
What was important for me to know if it was on the spruce or maple?
It was on the spruce, but one thing I can say is before choosing, we are aware of what you are saying, and what we noticed is we observed it carefully everywhere, like maple and spruce surfaces, under the in-situ microscope, under UV light, under the UV light. I mean, the microscope is also equipped with UV light, and we looked everywhere. We compared, in a way, our observation between the maple and the spruce. And we noticed it was very similar this way. And we also noticed the presence of the red particles everywhere in the original varnished areas.
My question was more about the protein you can find or not.
There was no...
Because many makers even today use blue or eggs for put only on the top, but not on the back. It was...
Yeah. I'm well aware of that. And on the whole set of the strads, we sampled almost half on spruce and on tops, half on the maple, whether on the head, on the scroll, or on the ribs.
But the Provigny has incredible varnish.
Oh yes, I agree.
I enjoy it so much. Thank you, Jean-Philippe.
You're welcome.
Okay, next is Gerten.
Gerten, where are you?
Jean-Philippe, thank you for your very interesting presentation.
Thank you.
My question is the following. So I was intrigued by your experiments with the colophon and the oil, and with the various ratios of the recipes. It was very interesting to hear that the optimum recipe had a lot of colophon and relatively little oil. So normally you associate the colophon with a very brittle varnish.
Mm.
So my question to you is, do you think that the cooking circumstances that they have, and the bonding of the oil and the resin, that they alter the properties of the finished layer?
Yes, thank you, Gerten, for your question. Very good question. In fact, in the course of the research of my PhD student, Sophie, we studied only a very limited aspects, which was how the chemistry was evolving in the first early times of the drying of the film, and how it would apply, how it would be easy to apply. Because the PhD was 3 years long only, we left the films to dry only 1.5 years or something like that before this kind of time, you know, between 1 and 2 years long of aging. And then we measured the chemical composition. We didn't see any specific brittling after this short time. And it was not the goal of the study. Another study should be made now with the thing about long-term aging, because probably what we found, I mean, we didn't say what is best and what is not good. We say, here are the differences. And just for some aspects. And the long-term aging and the quality of the film maintaining the thing has not been studied. So you would know better, I mean, you all would know better than us.
Yeah, well, what my experience is I made quite a few oil varnishes, and when I made it with colophon only, it became already from the beginning very brittle. You could scratch with your nail. It was very also prone to damaging and to, so I think that I probably did the wrong time of cooking or temperature, and it would, I think, in your research for the future maybe be interesting to also to relate your circumstances of the making to the effect on the layer, the brittleness or whatever, and so yeah.
It's you know, you're totally right. I totally agree. You know, life, let's say life is short and it's all a matter of compromise. And we had, in like every experiment, we have to select, and it's always, it's killing to have to select the parameters.
I don't say what you have to do, but it's just, it was an idea. I maybe expressed it wrongly, but it would be an interesting path to maybe.
I think that the workshop and your community that is animated by Claudia could be, if we have a meta thinking, if I may, and think about finding a way with all the digital tools to share your individual experiences on topics. I don't know, it's like it would be called knowledge organization or something like that. But you have a huge amount of knowledge. We are 142 in this conference, and all of us could contribute brick by brick. It's like now it's kind of spread, and we have this occasion like today or this week to share. But it's, to me, this might be an interesting way to share.
Great idea, great idea. I totally agree. Thank you.
Okay, a question from George.
It's more of a comment than a question.
Okay.
So, I mean, the question of the oil getting too deeply into the wood. Obviously, if you just brush raw linseed oil onto your violin, it will soak in, and it'll take 10 or 20 years to dry. But one method is you can apply it with a cloth with a minute amount of oil on it, and you can put a minute amount on, let it dry, put another layer on, so you could actually build up a layer of oil that really doesn't penetrate at all. But another way is to use a very, very viscous oil, like a stand oil. In my case, I often use an oil that's been boiled with sulfur, which starts a lot of cross-linking, so it's actually quite rubbery at the time you apply it. So basically it doesn't flow at all. There's no capillary action. So, but there are many, many different ways you could do it, and they all look slightly different according to how you applied it and where it went in the wood.
Yeah, I thank you for, it's complementing totally what was trying to express. There are ways, probably a variety, a very diverse variety of ways to find solution. And it's too bad that when studying 300 or 400 years old varnishes, today's the chemical and physicochemical analytical tools do not allow to differentiate well enough between, let's say, standard oil and what was a raw oil, because aging over 300 centuries, it's kind of masking the chemical, the compositional differences between these things. The experimentation nowadays or reconstruction methods like you are doing are often the only way to go.
Absolutely.
Greg, would you like to say something? Unmute your microphone.
Yeah, well, I put in the comments just to interrupt that. If you, well, I often prime the oil with, besides cooking it and controlling the viscosity, prime the oil with a fine particulate matter like cabosil, a fumed silica. Mm-hmm. So this also is a way to control the depth of penetration of the material into the wood, into the head grain especially.
Thank you.
Last question. We should finish by 5. We are already half an hour late, and I think that these discussions could probably keep going for like weeks. So.
Yeah. John Arte, yeah.
Hi, Jean-Philippe. Thank you very much for today. It's wonderful. Hi. I wonder about the reliability of relying on being able to detect succinic acid in amber. The problem is that a lot of our cooking of varnishes is open pot cooking, and the boiling point of succinic acid is around, I think, 240 degrees centigrade. So in running amber, you're going to well exceed that temperature, and the succinic acid is probably going to disappear.
Yes.
Now, I wonder, Celine Daha's PhD thesis, she looked at some of the instruments that you've looked at, and she mentioned the possibility of 5% resin content in that lower layer that's on that instrument.
Yeah.
Now, I've often wondered whether something like spirit of turpentine mixed with linseed oil could provide enough of a masking component such that the resin acid that people like Raymond White have mentioned, it's an isopomeric acid of some sort. Apparently that's very, very easily masked by a very, very small amount of, say, colophony, or I'm wondering, say, spirit of turpentine. I'm wondering what your thoughts might be on that question.
It's thank you, John. It's totally completing things that I haven't been able to develop in my talk. And you're totally right about volatile or half volatile compounds that may disappear either during aging or either during the preparation process of the varnish. One thing it sounds like obvious to say, but we should say it more often, is we are able to detect only what is there when we analyze it. So everything that has gone before is not there anymore. It seems obvious to say, but of course, there could have been a spirit of turpentine. There could have been spirits to dilute the thing. But by definition, spirits, they evaporate. There could have been molecules before the cooking that have been evaporating or that reacted during the cooking and which disappeared as well. So we are shooting at a target that has moved, you know. What we are analyzing today is an old varnish, which is centuries old. And everything that has passed since is changing. It's like a veil that we are trying to remove to see the original past. But there is this veil of time, like a vagueness of our memories, if you could say, like a metaphor, that prevent us to have a very sharp and clear understanding, precise understanding of the past than we would have wished. And the succinate acid thing is one thing. The use of spirits is another thing. And there might be remains of half molecules, of half volatile molecules in spirit of turpentine, for instance, that are staying also. Because like the residue, the non-volatile residue of the spirit of turpentine might be saying, and Céline, she was my master's student. I didn't mention her work here, but she did a great job in the synchrotron experiments with me. Céline Daher, that you mentioned, discussed that really, and she's right, that a little part could hide a lot of things.
Yeah, I wonder. Thank you.
You're welcome. Thank you.
Thank you.
Okay, thank you very much.